Lesson 8.2, found on page 311, is very similar to lesson 7.3 of the previous chapter. So instead of writing expressions like we did in lesson 7.3, this time we're going to be writing equations. Remember from yesterday's lesson, an equation just means that there's an equal sign now. How do you write an equation to represent a situation? You can use what you know about writing algebraic expressions from lesson 7.3 to help you write algebraic equations. It's the same concept. We're just adding an equal sign now. A circus recently spent $1,650 on new trapezes. The trapezes cost $275 each. Write an equation that could be used to find the number of trapezes, T, that the circus bought. All right, so first we're going to circle the information that we need to write in the equation. So we know that they spent $1,650, and we know that each one costs $257. So what expression could you use to represent the cost of T trapezes? So if we just wanted to figure out an unlimited number of trapezes, in other words, not this specific amount, how much would it cost to buy T trapezes, however many we want to buy? Well, that's going to be $275 times T. Right? For every trapeze you buy, it's going to cost you another $275. The more mathematically mature way to write that, of course, is 275T. All right. So now we're going to write an equation for this situation. So the cost per trapeze, that's $275 each, times the number of trapezes, and then we also know the total cost for this particular situation. For this circus, they spent $1,650. So an equation that could be used to find the number of trapezes. So we want to figure out exactly how many they did buy. We're going to steal from over here. Is 275T equals 1,650. So that's their equation. All right, Ben, let's move on to our next situation here. Ben is making a recipe for salsa that calls for 3½ cups of tomatoes. He chops 4 tomatoes, which fill 2¼ cups. Write an equation that could be used to find out how many more cups Ben needs. All right, so how many cups did he actually fill? Well, he filled 2¼ cups so far with his 4 tomatoes that he cut up, plus the cups needed. We don't know how many more that is. That's what we're trying to discover. The total cups needed for the recipe was 3½ cups. So an equation that could be used to find the number of additional cups is 2¼ plus C equals 3½. We're not solving these equations, we're just writing them at this point in time. Later in the chapter, we're going to learn how to solve them. All right. Okay, 6 fewer than a number. Fewer means subtraction. Then a number is 46 3/33. So we're going to let n represent the unknown number. So that's going to be our variable. The phrase fewer than indicates subtraction. 6 fewer than a number. Remember that this is, in this case, is going to be a turnaround word. 6 fewer than this number. So that means we took 6 away from this number. So we've got n take away 6 equals 46 and 33/100. The word is means equal. All right, 2/3 of the cost of a sweater is $18. Let C represent the cost of the sweater in dollars. The word of indicates multiplication. And if that's not on your list from lesson 7.3, add it to your vocabulary list of operations. All right, 2/3 looks like that. 2/3 of the cost of the sweater, which was C, is 18. All right, now they're going to have us do a little more without quite so much help from them. They're going to release some of this responsibility to us now. Okay. Here, we're going to write word sentences for the equation. So we're doing the opposite of what we were doing before. They gave us the word sentence. We figured out the equation. Now they're giving us the equation. We're going to figure out the word sentence. So and what's our operation? Addition here. So I'm going to say the sum of A and 15. This equal sign indicates the word is 24. So what are we doing here? Oh, this is another way we could write this. We could say more than instead of the sum. There's more than one way to write out a word sentence for an equation. So we could say 15 more than A. 15 more than A. So 15 more than A. Once again, we could use the word equals instead of is. They're synonyms. All right, let's try this one over here. Let's see, R divided by 2/10 equals 40. Okay, so we're going to use the division answer word, which is quotient. The quotient of R and 2/10, we're going to say is 40. Okay, another way we could write this is R divided by 2/10. R divided by 2/10 equals, once again, equals and is are synonyms, equals 40. Okay, let's take a look at these next two. Explain how you can rewrite the equation n plus 8 equals 24 so that it involves subtraction rather than addition. Okay, think about your fact families from, like, I don't know, 2nd or 3rd grade, where you got those little triangle cards and you had a 24 and you had an 8 and an N in each of the corners, and this plus this equals that, this minus that equals that, this 24 minus n equals 8. Do you remember that? In other words, n plus 8 equals 24. 24 minus n will also equal 8. It's all part of the same family, addition, subtraction family. Or we could write 24 minus 8 equals n. And all of these will come out with the same answer for n. All right. So we could rewrite this. I'd say 24 minus, I'm going to say one of the terms. One of the terms equals the other term, right? So 24 minus n equals 8. 24 minus 8 equals n. Whichever one I subtract, it will equal the other term. So I could rewrite this as 24 minus n equals 8. And it's still part of the same addition-subtraction family. All right, one student wrote 18 times D equals 54 for the sentence. The product of 18 and D equals 54. So far that looks pretty good. Another student wrote D times 18 equals 54 for the same sentence. Are both students correct? Justify your answer. Yes, they are both correct, even though these two factors are flipped because of commutative property of multiplication. Commutative property of multiplication. Okay, because of commutative property of multiplication, the two factors can change places. It won't affect the answer. They can change places and it won't affect the answer. So in this case, it's 3, right? D equals 3 because 18 times 3 equals 54. 3 times 18 also equals 54. Because of the commutative property of multiplication, you can flip these two factors and you're still going to get the same answer. Okay, let's do one more before we look at our notes. Write an equation for the word sentence. 25 is 13 more than a number. Is means equal, more than means addition. So what operation does the phrase more than indicate? Addition. The equation is 25 is 13 more than a number. So I can do 13 more than a number, but because of commutative property of addition, I could also have flipped those, and this would still be a correct answer. But for the moment, just to keep it easier, because this is the order that they come in, we're going to do it in the same order. So 25 is 13 more than a number. All right, let's take a look at our notes. Okay, so we have, be sure to refer to your 7.3 notes for your operation words. Those really critical, that real critical list of operation words. It's going to help you so much. Is a new word that we've added, which means equals to. Of means to multiply. A number means you're going to be using a variable. So first you determine the operation. Then you're going to write the equation. A number divided by 5/10 is 29. A number divided by 5/10 is 29. M minutes less than 80 minutes is 50 minutes. So remember, less than is a turnaround word, meaning it doesn't get to go at the beginning. You have to flip it to the other spot. Okay, so in this case, it goes behind the 80. So 40 minutes, or I'm sorry, I don't know where 40 came from. M minutes less than 80 is 50. All right, and then the last example is write a word sentence. So here's our equation. 14 less than a number, which is our x here, is 52. So there's just a few examples for your notes.